nation, you know, 41.6 million for trying to prevent that. And therefore, we're losing 46 people in the last fire stats were killed due to electrical fires, and 2,469 were injured. And when I was looking at these figures, I say I put up England and Wales there specifically because, see, when you look at how do things apply to Scotland, you know, whatever it is, we generally take a figure of 10%, you know, for our budgets and such, you know. And so if you're looking at it from a stats point of view, you go, well, so how many people did we lose in Scotland last year? And so that if you look at that 4.6 people, so let's say 5 people. But actually, when you look at the stats, which if it comes up, yeah. So in Scotland, we lost 9 people to electrical fires. And then when you see the number of people we had injured, 598, this is substantially more than they have in England and Wales. There's actually, and there's something going on in Scotland which I haven't got the answer for today, but as I was preparing the talk, I thought that's worthwhile sharing with you. And one of the interesting facts that I came across, in Glasgow since 2000 and can't say there since 2010 anyway, Glasgow trading standards and such have basically confiscated 10,000 electrical goods that are false goods, you know. They don't do what they say on the tin. And actually maybe we have a real particular problem in Scotland, which is what, certainly from a Glasgow perspective, they certainly have identified that we have. And in the government statistics, I think it comes out down in England, but 25% of fires are down to electrical fires. In Scotland, it's 2/3 of fires. So there's a real issue with fires in Scotland. And therefore, how do we deal with that? And I'll come on to that in just a minute. So how do we deal with the guidance, you know, we'll deal with Scotland? Well, first we have our technical handbooks. And you know, I'm going through the guidance, and we have guidance on separating walls. Good guidance where we say, you've got a separating wall, you shouldn't have cables in it. And that's because we don't know what's happening on the other side of the wall. Cables can be damaged or whatever, or a fire breaks out. And this is an internal wall, but you can see the damage that can take place. That photo actually is from the bottom guidance document. It's the electrical installations and their impact on fire performance in buildings. And if you haven't seen that guidance document for any of you, it's actually worth having a look at. It's a really good document put out by Electrical Safety First, which is overriding charity body for electrical work. And it looks at particular things like downlighters and such in houses with modern joists and such, you know, or engineered joists compared to just your standard joists, what you should have and such. So it's a really good guidance document. But as regarding the technical handbooks, we have something in separating walls, but then for openings, we allow you for compartment walls and separating walls to put cables through, and all we ask is that you fire seal around the cables. When we come to surfaces, we talk about cavities within buildings, but we specifically exclude cables from it. But we're finding more and more cables are you know, our buildings are festooned with cables, and it definitely seems to be a problem. So we don't really deal with it from a national point of view, and it's the same in England, well, throughout the UK. From a national standards point of view, UK government, as we don't really deal with cables. It's all left to industry through BS 7671, and that really only touches on cables if we're providing fire safety measures, you know, like fire alarms and such, and saying, you know, it'd be a good idea to use a non-burning cable, use a cable of a specific fire resistance. So we're relying on professional expertise in writing this guidance document and then going out and signing a building to say that it's okay. And is that okay? You know, is that an appropriate way forward? And actually, much like all regulations, we seem to react to incidents, and this is no different. I thought it was worthwhile bringing this up. This requirement came in 2015 But I've had various conversations with people over the years, particularly over the last year or two, and fire risk assessors, and they weren't aware of this change. So there's been a number of fires where firemen have lost their lives, and cables have possibly played a part in that. And at the coroner's investigation into the Grenfell Tower fire down in Berwickshire, I think it was, the coroner says we really have to do something to address this, and it recommended that the guidance was changed. And what's happening is, you'll all be familiar with it where a building is renovated, or housing and such in particular, with the plastic tubing that runs, you know, at high level around the building, and in the fire naturally that just melts away and just falls down and creates a hazard for any occupants trying to get out, or the fire service that's trying to come in. And as I say, it has led to the deaths of firefighters. So what this says is we have to update the guidance. And as I say, the guidance is not government guidance, it's industry. So BRE, in support of that, they wanted to look at, well, what are there products and such out there that will help deal with a situation. So they set up a test rig, basically a room with concrete and timber beams over the top of it, so that you could screw fixings into, and they put up 5 cables there, as you've seen, and then basically set a fire, you know. And it demonstrated that as long as it's non-combustible fixings, you know, your metallic fixings and such that you put up there, then the cabling will stay in place. But one of the things that did come out in it was, you have to remember, if people are fixing cables up there, that you know, if you put a plastic raw plug and you put a metal screw in it, that in a fire, then the raw plug is just going to disappear. So they therefore rewrote their guidance, and basically says that if it's an escape route, that your cables have to be appropriately supported by a metallic or non-combustible fixings, which is you see your normal metallic saddles and such that's used. You could still have it in plastic, you know, in a plastic surround and such, but as long as you've got the non-metallic fixing, as you can see here at the front, this is again from their test, you can see from the front that the cables won't fall away, and so therefore it keeps them out the road. Now, so that's a sign of, you know, industry reacting, you know, to an issue that's been identified. But what it all does is show, I think cables have been very much overlooked, you know, from a fire point of view. And I think it's up there just talking about that, you know, the fire service are talking about, you know, how they're going into fires, huge amounts of toxic smoke given off by cables. And these cables are running everywhere, you know, under floors and such. You know, if you go into a typical office building, you've got cables going to all your standard sockets and such, all around, you know, each office, each desk wants to have all their own cables. We've got our IT hubs and such, never mind all the factors that we put in for fire safety and such. But depending on the cable that goes in, it can be a high fire risk. And I'm sure if I asked any of you in the room, you know, how do you know what your rating of your fire cable is? You wouldn't know. We all recognise it. We've seen the drums that go in buildings, just grey cable, and that's it. If you're a fire risk assessor or designer, you really don't know. Now, that BS 7671 recognised that you do need fire rated cables in certain conditions, and it came up with a recommendation that you should have halogen free cables in certain conditions. Now, this is, I've kept the right page, hopefully I'll be able to read this out to you. But yeah, but what they describe, it's low flame cables and such, and they have like 3 different criteria, and they're quite confusing. But not only that, here's low smoke, 0 halogen, low smoke and fume, 0 halogen, low smoke, and that's 3 different criteria. I mean, and how do you know you're using the right one? And then there's nothing to tell you what cable you should be using in what particular situation. PVC, as I mentioned up there, you know, when it's burning, first it releases chlorine gas, which is obviously nasty stuff, and totally disorientate you and affecting your breathing and such. Before, you know, as it really gets going and it's getting off this smoke and the impacts that have, then you get your carbon monoxide, carbon dioxide. So it's not a good thing. And then once you wet it, it then gives off hydrochloric acid. So even if it's a small fire or whatever, then all your equipment's knackered and such. So industry therefore recognises this, but possibly they're not going far enough. So this is not just a problem in the UK, it's a problem, you know, across the world and throughout Europe. And Europe's been working with industry in the UK and elsewhere. How do we deal with this? And I thought I would share this with you because, you know, we're all quite busy and you may not be aware of it. But what they've done since July this year, it's now a requirement that manufacturers can no longer supply a cable to you without telling you what the reaction to fire performance is. So all your grey cables they all now need to have a performance. And as a designer or a fire risk assessor on that, you can say, well, what's the performance of the cable in this building, or indeed what it should be. And it's because they finally put out this harmonised, well actually I think it's BSEN 50575, and it's all about cables going into different types of buildings and such. So what they've recognised is industry, you know, from an insurance point of view and such, if you're putting stuff into buildings, they want it to have a particular fire rating. You know, you're putting, spending millions and such on your communication systems, you do not want to lose that in the event of a fire. So insurers and such are deriving, saying, well, you've got to put in an appropriate cable. It's the same for like hospitals and such, you can't have areas going down in the event of fire. So Europe is trying to harmonise all this, and therefore this new standard that they've brought in is about bringing in that classification system with a clear reaction to fire. Now, what is it? What's the reaction to fire test that they're doing? And this is where we come into what should be recognisable really to us all. They're looking at the energy content that comes off when you burn the cable. They're looking for the spread of fire on a cable, the acidity. You know, I mentioned earlier that once water goes on the ordinary PVC, you get hydrochloric acid. They're looking for, I can't actually see it, looking for the heat output and looking at flaming droplets. All of that there should be familiar to anyone that uses the technical handbook, because it all reflects what's in the reaction to fire tables within the technical handbooks and the annexes. Now, what I've done is I've kind of pulled it all together into a table. In fact, you can't see that, so if I just pull up a particular part there, and they've rated it from A down to F, and it's just, I mean, all it's doing is it's giving you your vertical spread of flame characteristic, and then it's giving you, you know, taking you through a number of tests for a burn characteristic. And with the part that I've highlighted there, you can see it's giving you the actual test, the kilowatt, 20.5 kilowatts and such. But out of that test, your criteria is totally different. You know, one that's 15, another one that's 30 kilowatts, another one that's like up to 500 kilowatts and such. So it gives you clear criteria that it has to meet, as well as, you know, if there's any flaming droplets and such. But all of that just reflects what's in the technical handbook, particularly for the reaction to fire, the Annex 2F, is it, for roofs and such. It's just really very similar to that. So now, if you're looking for cables for buildings or anybody's designing them, it's really clear, I want a Class B, I want a Class A or whatever, just like you do for any other reaction to fire. So I'd been in discussions with the British Cable Association, and they were saying that you should always specify cables that have a CE mark, and you've got to do that now, and it has a declaration of performance, basically telling you it's been tested in accordance with X, Y, and Z, and this is its rating. Now they recommend you should be specifying a cable of E or above. Now the classification goes from A to A, and just a wee quote there from when I was speaking to them, and they're saying, well, I was saying, so you're recommending from E to above, and he's going, yeah, because if you use class F, which is kind of like your standard grey cable that we have, it's going, yeah, if you use class F, it says it burns like a candle, so you wouldn't recommend that, you know. So just to quote him. So what's interesting is you look at this box here. So they recommend that you're using a low risk, but they're saying it should be class E and above, and include for smoke, acidity and flaming droplets. So they even go above, you know, it's class E, but we want these other requirements. That's their minimum recommendation for buildings. And there, as I say, that's on from their website. You avoid cables classified as FCA, as they're likely to burn uncontrollably in a fire. So now, you know, we've been on many a job where we're firing this stuff in, oblivious to the actual risks we're putting into buildings. It's now quite clear. In fact, some manufacturers are just going that wee bit further and making it clearer for us. This is Brand Rex, one of the suppliers, and what they've done is they've colour coded it. And they're colour coding their cables so that when you go out and you're doing a fire risk assessment or whatever, it will be banded, it'll have bands on it, and you know that's an orange cable, that's class BA or BCA as it is. And not only that, they give recommendations for what buildings it should apply to. So, for instance, you've got your B2, that's hospitals, airports, high assembly buildings, or where you might expect people, you know, to have a delayed escape and such and need assistance. Class CA, it's public buildings and schools and such, where people are alert and can quickly self-evacuate, down to just more your standard run-of-the-mill buildings.
Is that just reaction to fire?
It's just reaction to fire. They're actually looking at doing a standard, bringing out a harmonised standard for fire resistance and such for your actual fire cables, but it's not out yet. They're working on that. So this is just reaction to fire.
So where's that table from?
This is a manufacturer, brand Rex. I spoke to the guy on the phone, and he was saying that other manufacturers and such are looking at a similar thing, but it's not adopted by industry. But it's a really good idea if they do, you know. It just makes it so much easier if you're going out to inspect, you know, or know what.
So if you go to guys like Prismy, they'll tell you the amount of money that they're spending trying to stop Chinese counterfeits.
Yeah.
And so now you'll just get this where it comes in the right colour and then you'll go, that's fantastic.
Well, it's back to what we're saying with Glasgow, with you know, 10,000 goods that they've impounded just over the last year or two, you know. So that's definitely a real problem. And that's the same. Well, there's one with the glazing and such come up recently as well. So, but that really kind of concludes my talk. It's just to bring you up to speed and let you know that this document is out there, and it is of benefit to the industry, because it allows you to ask really simple questions. You know, is it a low zero halogen cable, whatever? Very confusing and such. There's a new system, reaction to fire. We actually all know that terminology and such, and you know, it's far easier to identify it. Is that cable that you're putting in appropriate for that type of building? Before, I think it would be very difficult to, you know, ask those questions.
How engaged are the industry?
Well, I only know with the people I was speaking to, but I spoke to the British Cabling Association and a couple of manufacturers, and what they were telling me is they've been involved through the process.
Because my experiences with the ductwork industry, and that is an absolute nightmare. You know, they've had a harmonised standard since 2013, and none of them will see mark anything.
Yeah.
And so anytime you put it in your spec.
Yeah, the big.
Just go back and say, oh, we can't source any of this stuff because nobody makes it.
But the big difference is we had an opt-out in the UK on the construction products, as it were, and we did, although things should have been CE marked and such, we kind of had an opt-out of that, so it wasn't mandatory in the UK. That's changed under
even for 2013.
Yeah, but I can't. Time flies with me, but I don't know when the construction product regulation has changed and come back in. I do think it's quite recent, and it's only since then that it's become mandatory in the UK. So it is, I mean, 2 years max, I would have said, but I don't know if it's as long as that.
See, in terms of your general conversations with people in the industry, John, you were talking about the 18th, that is the 17th or 18th edition of 767 London.
18th, yeah.
Understanding from, I'm not electrically advised, but understanding from reading some of the stuff that's going out there is that you can eliminate quite a lot of the cable faults that you get by putting proper fall protection or fall protection. So if you change the guidance in terms of the way that you put protective devices on the supply end, whether it be a minor circuit or a local or a major circuit, you can actually stop the ignition energy getting to the cable or bad point in the cable where you have the problem.
Yeah.
If you put it appropriate after that fall and protection at the supply boxes.
Yeah, it's interesting because actually I was reading, sadly I was reading forums and that kind of thing come up. But one of the things that they were highlighting is, as soon as if you get cables and you get arcing and such, then that's going to trip your RCD, and you're protected that way. Whereas I find out that's not necessarily the case, and go on the internet, you can see it on YouTube where people are doing these tests and saying, yes, we need to change our guidance and such to put. You can, but yes, and you need that industry agreement. Yeah, no, it's a really good point, Glenn, and it's been discussed out there. But as I say, it's an industry document that's driven by industry, and therefore you get a lot of compromise. So I hope that was interesting.
Yeah, great. Thank you.